In this video I'm going to talk about the potential divider circuit, and it's analogous with this situation here. Let's say I have a bucket of water and I raise it up a certain height h, therefore it has gravitational potential energy mgh. Then if I was to move along horizontally, I would do no work on the bucket of water. Then if I first pour out the bucket of water to this height here, it will have lost gravitational potential energy mgh1. If this height here, let's say this height here is h1, and if it was to pour out again from this level down to the ground, it would lose gravitational potential energy mgh2, and the sum of these two, mgh1 plus mgh2, should equal mgh due to conservation of energy, giving no other losses. So this is analogous with the potential divider circuit here. Here we have a battery which is providing V total electrical potential energy, and then the current is sent along the circuit, and let's say V1 of that gets used up in resistor 1, and then V2 gets used up in resistor 2. Well, the question is, can we find an expression for the potential used up across resistor 2, V2, or indeed the potential across resistor 1, V1? Well, we know that, I'll do it up here, V equals I times R times the total resistance. So I equals V over RT. But we know from the conservation of energy that V total equals V1 plus V2, analogous to here, mgh1 plus mgh2 equals mgh. We also know that V1 is the current times resistance 1. So therefore, if we substitute with this I in here, we get V1 equals V over R total times R1. And since these are connected in series, we know from the previous video that the total resistance of resistance series is just R1 plus 2, the algebraic sum of the two resistances. So we have an expression for potential across V1 is total potential times by R1 divided by R1 plus R2. So we can say that R1 takes its share of the total potential, and therefore V2 equals V times R2 over R1 plus R2. For example, if resistance R1 here was 10 ohms and R2 was 20 ohms, then R1 would take 10 divided by 30, i.e. a third of the total potential, and R2 would take 20 divided by 30, since 30 is the total potential, total resistance of the total potential.